Adding complex numbers. The rule for adding complex numbers is we add the real parts with the real parts and the imaginary parts with the imaginary parts. Z1 equals 2 plus 3i and Z2 equals 1 plus 5i. Evaluate Z1 plus Z2. So we have to add this complex number Z1 with this complex number Z2. So Z1 plus Z2 is going to be 2 plus 3i plus 1 plus 5i. So we take the real parts, which are basically just the parts that don't have I stuck on, which is 2 and 1, and we add them, and 2 plus 1 gives us 3. So the real part of our answer is 3. Then we take the imaginary parts, the parts with i's stuck on, which is 3i and 5i, and we add them, and 3i plus 5i is 8i. It's very similar to adding 3x plus 5x, which would give us 8x. So the answer, Z1 plus Z2, is 3 plus 8i, where 3 is the real part, or e, and 8i is the imaginary part, im. Another way of doing it is setting it up with Z1, the first complex number, 3 plus 2i, inside a set of brackets, a plus symbol in between because we're adding, and 1 plus 5i, which is the other complex number, in another set of brackets. There's nothing stuck onto the front of this bracket, so we just write down the 2 plus 3i, and then we multiply in the plus. Plus times 1 is plus 1, plus times plus 5i is plus 5i. Next we simplify. 2 plus 1 is 3, so we put the real parts together, and 3i plus 5i is 8i. We put the imaginary parts together. This method is very, very useful if we're subtracting complex numbers, which is what we will see in a minute, because using this method for subtracting can lead to mistakes, but using this method when we're subtracting is much more accurate. Subtracting complex numbers. Take the real parts from the real parts and the imaginary parts from the imaginary parts. So Z1 equals 8 plus 6i and Z2 equals 4 plus 2i. Find Z1 minus Z2. So Z1 minus Z2 will be 8 plus 6i, which is Z1, minus 4 plus 2i, which is Z2. So we're going to take the 8 and the 4 and subtract them, because we subtract the real parts from the real parts, and 8 take away 4 is 4. So the real part of our answer is 4. Then we take the 6i and the 2i and we subtract them. 6 minus 2i is 4i, because 6 minus 2 is 4. So the imaginary part is 4i. So Z1 minus Z2 is 4 plus 4i. So just because we're subtracting doesn't mean we necessarily end up with a minus. It's important to note that Z2 minus Z1 would give us a different answer. So this is the other method, where we write Z1 down, which is 8 plus 6i, with brackets. Then we write our minus, and then we write Z2 down, which is 4 plus 2i with brackets. There's nothing stuck on to the 8 plus 6i, nothing stuck onto the front of the bracket, so we just straight away write down the 8 plus 6i. There's a minus stuck onto the front of this bracket, so we multiply in the minus. Minus multiplied by 4 is minus 4, and minus multiplied by plus 2i is minus 2i. Next we put the real parts together. 8 minus 4 is 4, and 6i minus 2i is plus 4i. So again we get 4 plus 4i for the real part and the imaginary part. Z1 equals minus 4 minus 2i, and Z2 equals minus 3 minus I, which is really minus 1i. Find Z1 minus Z2. So we write down Z1, which is minus 4 minus 2i, in brackets. We bring down our minus, and then we write down Z2, which is minus 3 minus I, in brackets. There's nothing stuck onto this bracket, so we just straight away write down the minus 4 and the minus 2i. There's a minus stuck onto this bracket, so we have to multiply in the minus. Minus times minus 3 is plus 3, and minus times minus I is plus I. A minus by minus is a plus. Next we simplify. We put the real parts together and then the imaginary parts together. Minus 4 plus 3 is minus 1, that's the real part. And minus 2i plus 1i is minus 1i, or just minus I, that's the imaginary part. Now we're going to work out Z2 minus Z1, and we're going to see that we end up with a different answer. So we write down Z2, which is minus 3 minus I. We bring down the minus, and then we write down Z1, which is minus 4 minus 2I. Again, there's nothing stuck onto this bracket, so we just straight away write down the minus 3 and the minus I. There is a minus stuck onto this bracket, so we have to multiply it in. Minus times minus 4 is plus 4, and minus times minus 2I is plus 2I. Next, we put the real parts together. Minus 3 plus 4 is 1, so that's the real part, 1. And minus I, which is the same thing as minus 1I, plus 2I gives us 1I, which is the same thing as just plus I. So that's the imaginary part. So notice that Z1 minus Z2 gave us an answer of minus 1 minus I. And Z2 minus Z1 gave us an answer of positive 1, positive I. So we get different answers depending on the order in which we're subtracting. Multiplying complex numbers. If Z equals 4 plus 2I, find 3Z. So 3 and Z are stuck together, and anything stuck together in maths means multiply. So we're going to multiply the 4 plus 2I by 3. So 3 multiplied by Z is going to be 3 multiplied by 4 plus 2I. Make sure that you use brackets. 3 multiplied by 4 is 3 multiplied by 4, which is 12. And then 3 multiplied by 2I is 3 multiplied by 2I, which is 6I. So 3Z is 12 plus 6I. 12 is the real part, 6I is the imaginary part. Always make sure the real part comes first. Z1 equals 2 plus 4I. Z2 equals 2 plus 3I. Z3 equals minus 1 plus 2I. And W equals 1 plus I. Part 1. Plot Z1, Z2 and Z3 on an Argand diagram. So Z1 is 2 plus 4I, so we go to 2 on the real axis and 4 on the imaginary axis. So we go to 2 on the real axis, 4 on the imaginary axis, and we plot the point Z1. Next we have Z2. Z2 equals 2 plus 3I, so we go to 2 on the real axis, 3 on the imaginary axis. So 2 on the real axis is here, and 3 on the imaginary axis is here. So we plot the point Z2. Z3 equals minus 1 plus 2I. So we go to minus 1 on the real axis and 2 on the imaginary axis. So we go across to minus 1 on the real axis, and we go up to 2 on the imaginary axis. So we plot the point Z3. Part 2. Evaluate Z1 plus W, Z2 plus W, and Z3 plus W. So Z1 is 2 plus 4I. So we have 2 plus 4I, and we want to add the complex number W, which is 1 plus I. So we're adding 1 plus I. Adding the real parts, 2 plus 1 gives us 3. And adding the imaginary parts, 4I plus 1I gives us 5I. Next we're going to work out Z2 plus W. So Z2 is 2 plus 3I. We're going to add, and W is 1 plus I. We're going to add the real parts with the real parts and the imaginary parts with the imaginary parts. So 2 plus 1 is 3 for the real parts, and 3I plus 1I is 4I for the imaginary parts. Next we're going to work out Z3 plus W. So Z3 is minus 1 plus 2I. So we have minus 1 plus 2I, and we're going to add W, which is 1 plus I. So again, we add the real parts with the real parts, the imaginary parts with the imaginary parts. So minus 1 plus 1 is 0, which just cancels out. And 2I plus 1I is 3I. So we get 0 plus 3I. Part 3. Plot the answers to part 2 on an Argand diagram. So we got Z1 plus W to be 3 plus 5I. We got that in the previous slide. 3 plus 5I. We got Z2 plus W to be 3 plus 4I. So Z2 is 3 plus 4I. And we got Z3 plus W to be 0 plus 3I. That's 0 plus 3I. Remember that Z1, Z2 and Z3, the dots drawn in black, were the complex numbers given in the question. Z1 Z2, and Z3. And what we did was we added this complex number to each of them. And notice that what has happened is each complex number has been moved in the same direction by the same distance. So what has happened is the complex numbers have been translated. Part 4. Describe the transformation that is the addition of W. So basically describe what happened when we added W to Z1, Z2 and Z3. So from the Argand diagram, the numbers Z1, Z2 and Z3 are moved the same distance and in the same direction. We call such a transformation a translation. So we can see Z1 was moved this distance in this direction. Z2 was moved the same distance in the same direction. And Z3 was moved the same distance in the same direction. Z1 equals 2 plus 4i. Z2 equals 2 plus 3i. Z3 equals minus 1 plus 2i. And a is equal to 2. Part 1, plot Z1, Z2 and Z3 on an Argand diagram. So Z1 is 2 plus 4i. So we go to 2 on the real axis, 4 on the imaginary axis. So go to 2 on the real axis, and we go to 4 on the imaginary axis, and we plot the point Z1. Z2 equals 2 plus 3i. So we go to 2 on the real axis, 3 on the imaginary axis. So we go across to 2 on the real axis, up to 3 on the imaginary axis, and we plot the point Z2. Z3 is a complex number minus 1 plus 2i. We go to minus 1 on the real axis, 2 on the imaginary axis. So we go across to minus 1 on the real axis, and up to 2 on the imaginary axis, and we plot the point Z3. Part 2. Evaluate AZ1, AZ2 and AZ3. So the A is stuck onto Z1, it's stuck onto Z2 and it's stuck onto Z3. And anything stuck together in maths means multiply. So A Z1 means A multiplied by Z1. And A is 2, so it's 2 multiplied by Z1, which is 2 plus 4i. So we have 2 with a set of brackets and 2 plus 4i inside. It's very important that you multiply the 2 by the real number and the imaginary number. So 2 times 2 is 4, and 2 times 4i is 8i. So AZ1 is 4 plus 8i. AZ2 is A multiplied by Z2. A is 2, and Z2 is 2 plus 3i. So it's 2 multiplied by 2 plus 3i. So 2 times 2 is 4, and 2 times 3i is 6i. And AZ3 is A multiplied by Z3, and A is 2, and Z3 is minus 1 plus 2i. So it's 2 times minus 1 plus 2i. So 2 times minus 1 is minus 2, 2 times 2i is 4i. Part 3. Plot the answers to part 2 on an Argand diagram. So AZ1 we worked out to be 4 plus 8i. AZ2 we worked out to be 4 plus 6i. And AZ3 we worked out to be minus 2 plus 4i. So notice that the point Z1, if we connect it up to the origin, which is the center 0, 0, is along the same line as AZ1. So its distance from the origin is different, but it's going in the same direction. And the same can be said for Z1 and AZ2. They are along the same line connecting to the origin. And the same with AZ3 and Z3. They go along the same line connected to the origin. Part 4. Describe the transformation that is multiplication by A. From the diagram, we see that all the points are moved further from the origin by a factor of 2. So we can see that AZ1, again, is along the same line connecting Z1 to the origin. It's just been moved further away, as has AZ2 and as has AZ3. We call such a transformation a dilation by a factor of 2. If F is the dilation factor, and f is greater than 1 or f is less than minus 1, the dilation is sometimes referred to as stretching on the complex plane. But if f is between minus 1 and 1, the dilation is sometimes referred to as contracting on the complex plane. Multiplying complex numbers. If z equals 4 plus I, find iz. So now we're going to multiply a complex number by I this time. So I stuck onto z means I multiplied by z. So we're going to have I multiplied by 4 plus I because z is equal to 4 plus I. Make sure you use brackets. And we're going to multiply the I by the real part and the imaginary part. I times 4 is 4I. We always put the number first. And I times I is I squared. Just like x times x is x squared or y times y is y squared and so on. I times I is I squared. Now we know that I squared is equal to minus 1. So we can swap this I squared for minus 1. So we have 4I minus 1. And then we just rearrange it to make the real part be first. So the minus 1 goes in front. That's the real part. We know this is real because there's no I stuck onto it. And there's no I stuck onto it because the I squared became minus 1. And then the 4I comes second because that's the imaginary part. So iz equals minus 1 plus 4I. So z1 is 2 plus I. We want to find z2 if z2 equals I z1. And I z1 means I multiplied by z1. So we're going to multiply z1, which is this complex number 2 plus I, by the letter I. So I times z1 is going to be I times 2 plus I. We're going to multiply the I part by the real part and by the imaginary part. So I times 2 is 2I. A number times a letter, we stick it together. Just make sure the number part comes first. And I times I is I squared. Now again, we know that I squared is equal to minus 1. And we put that first because the real part must come first. And we bring the 2I down second. The imaginary part must come second. So z2 equals minus 1 plus 2I. Part 2. Plot z1 and z2 on an Argand diagram. So z1 was 2 plus I, or 2 plus 1I. So that's z1. And z2 was minus 1 plus 2I. Minus 1 plus 2I. Part 3. Describe the transformation that maps z1 onto z2. z1 is mapped onto z2 by an anti-clockwise rotation of 90 degrees about the origin. So basically we have formed a right angle, a 90 degrees angle. And if we think about it, if z1 was rotated to the left, which is anti-clockwise, and ended up at z2, it would have moved 90 degrees. It would have been rotated an angle of 90 degrees. So multiplying a complex number by I rotates it by 90 degrees. z1 equals 2 minus 7i and z2 equals 3 plus 7i. Find z1, z2. So z1 and z2 are stuck together. z1 stuck onto z2 means z1 multiplied by z2. So any two things stuck together in maths means multiply. So it's going to be z1 multiplied by z2. z1 is 2 minus 7i, so we stick brackets around it. And z2 is 3 plus 7i, so we stick brackets around that. So this is very similar to algebra, where we have binomial expansion, or you may know it as cracking open the egg. So we multiply this set of brackets, or this egg, by this set of brackets, or this egg. So we put a crack after the first number, so that's after the 2 and in front of the minus. The 2 falls down here. We did not crack open the second egg, so we just stick that on. And then the minus 7i falls down here, and again we did not crack open the second egg, so we just stick that on. 2 times 3 is 6, and 2 times 7i is 14i. Minus 7i by 3 is minus 21i, and minus 7i by plus 7i is minus 49i squared. Because remember, I times I is I squared. And we bring down the 6, And plus 14i minus 21i gives us minus 7i. We bring down the minus 49 and I squared becomes minus 1. Now very, very, very important. We must use brackets here because the I squared was stuck onto the 49, so we're multiplying them. So it's going to end up being minus 49 multiplied by minus 1. And that gives us plus 49. So we still have the 6 and the minus 7i, but now we have plus 49. Next we put the real parts together, so that's anything without an I. So 6 plus 49 is 55, and then we just bring down the minus 7i because there's no other i's to put it with. So Z1, Z2 equals 55 minus 7i. Make sure the real part comes first. Part 2. Z1 equals a half minus 3 over 2i, and Z2 equals 4 plus 6i. Find Z1, Z2. Remember, two things stuck together in maths means multiply. So we're going to multiply Z1, which is this, by Z2, which is this. So Z1 times Z2 is going to be a half minus 3i multiplied by 4 plus 6i. So we stick brackets around the first complex number and we stick brackets around the second complex number. And then again we crack open the egg. So we crack open the egg in between the half and the minus, and the half falls down here. We did not crack open this egg, so we just stick it on. The minus 3 over 2i falls down here, and again we stick on the second egg. A half times 4 is 2, a half of 4 is 2, and a half times 6i is 3i, a half of 6 is 3. Minus 3 over 2i times 4 is minus 6i, so you can just stick into the calculator minus 3 over 2 multiplied by 4, which will give you minus 6, and just stick on the I. And minus 3 over 2 times 6 will give you minus 9, and I multiplied by I gives us I squared. We bring down the 2. 3i minus 6i gives us minus 3i. We bring down the minus 9, and then the I squared becomes minus 1. Make sure you've got brackets around it because the 9 and the minus 9 and the I squared are stuck together, which means we have to multiply them. So it becomes minus 9 multiplied by minus 1, which is plus 9. We still bring down the 2 and we still bring down the minus 3i. Next we put the real parts together. That's anything without an I. 2 plus 9 is 11, and then we bring down the minus 3i. Make sure the real part comes first. So the answer is 11 minus 3i.